Hi all, welcome to our channel. In today's video, I am going to explain about what is a sorting technique, what are the different types of sorting techniques, what is meant by bubble sort, what is the logic of the bubble sort with an example, and I am going to show the animation of the example, and I will explain about the algorithm as well as tracing of that algorithm, and I am going to explain the time complexity of bubble sort. Finally, I will explain about the program of this bubble sort. Okay. So first of all, what is meant by a sorting technique? Sorting technique is nothing but arranging the elements in some order, whether it may be in ascending order or descending order. Okay. Sorting is nothing but arranging the elements in some order, whether it may be in ascending order or descending order. Ascending order is nothing but like 1, 4, 8, 9. Descending order is nothing but this one 9, 6, 3, 1 like this. Okay. So arranging the elements in some order is nothing but sorting technique. Next, what are the different types of sorting techniques? Okay. In general, types of sorting techniques are comparison based sorting techniques, comparison based sorting techniques, as well as non-comparison based sorting techniques. There are two types of sorting techniques: comparison based sorting techniques as well as non-comparison based sorting techniques. What is meant by comparison based sorting techniques? Okay, by comparing the elements, whether they are adjacent elements or the elements which are at some distance, or the first element or last element, whatever it may be, by comparing the elements of the list we can sort the elements. Okay, so those kind of sorting techniques are known as comparison based sorting techniques. Examples are like bubble sort, as per our syllabus, bubble sort. Next, selection sort. Next, insertion sort, like merge sort, quick sort. Okay, like this heap sort and so many other sorting techniques are there coming to the comparison based sorting techniques. Whereas coming to the non comparison based sorting techniques means without comparing the elements, also we can sort the elements. Those techniques are radix sort, bucket sort, count sort. Radix sort, bucket sort, as well as count sort. Okay, so in general these are the types of sorting techniques: comparison based as well as non comparison based. But from some others point of view, sorting techniques are two types, like internal sorting techniques as well as external sorting techniques. Okay, what is meant by internal sorting techniques? If our primary memory is capable of holding all the data, if our primary memory is capable of holding all the data inside it, then if we perform the sorting technique there, then it is known as internal sorting techniques. Okay, what is meant by external sorting techniques? If our primary memory is not capable of holding all the data, that means if our input size is very large, then obviously we can go for secondary memory. Okay, if we perform the sorting technique there, then it is known as external sorting technique. Okay, so all these are the techniques of internal sorting techniques. Next, coming to this one, bubble sort, selection sort, insertion sort. In general, coming to these three time complexity, these three algorithms time complexities are big O of n square in general. Okay, whereas coming to the merge, quick, as well as heap sort, time complexities are order of n log n. The time complexity of these three sorting techniques are order of n log n. Okay, how to calculate the time complexity I will explain later. In general, the time complexity of bucket sort, radix sort and count sort is order of n, order of n. Okay, even though the time complexity of non comparison based sorting techniques is very less when compared to the comparison based sorting techniques, but the memory is taken by the non comparison sorting techniques is very high. Okay, so the first one is bubble sort. Bubble sort is the simplest sorting technique, which is very simple logic. Okay, so coming to the bubble sort, what is the logic of the bubble sort? Compare the adjacent elements, compare the adjacent elements, very simple logic. If the elements are out of order, if the elements are out of order means not in the order. Okay, if the elements are out of order, then swap them, then swap. Okay, otherwise means if they are in order, not out of order, no need to swap the elements, no need to swap the elements. Okay, no need to swap the elements. Repeat this logic up to all the elements are in the sorted order. Okay, up to all the elements are arranged in sorted order. This is the logic of bubble sort. Why the name is bubble sort? If you pour the water into the bucket, generally what will happen? Bubbles will move up to the surface. If we perform the sorting technique by using bubble sort, then largest element will go and sit at its right place. Okay, like bubbles come up to the water, largest element will go and sit at its right place. Next, coming to the example of the bubble sort, consider the list of elements 9, 6, 4, 1, 2. So the n value is 5. There are 5 number of elements. What is the logic of the bubble sort? Compare the adjacent elements. Okay, so the first one is 9 and second one is 6. Compare 9 and 6. If they are out of order, here 9 is greater than 6. Yes, condition is true. So if they are out of order, then swap them. Swap these two elements, 6, 9, 4, 1, 2. Next, compare the next adjacent elements 9 and 4. 9 is greater than 4. 9 is greater than 4. So swap these two elements, 6, 4, 9, 1, 2. Next, repeat the same process. Compare 9 and 1. 9 is greater than 1. So swap these two elements. That is 6, 4, 1, 9, 2. Next, compare 9 and 2. 9 is greater than 2. So swap these two elements. 6, 4, 1, 2, 9. There are no other elements to compare. So at the end of the first pass, largest elements in its right place. Largest element in its right place. This is the end of the pass 1. This is the end of the pass 1. At the end of the pass 1, largest element in its right place. Next, coming to the pass 2. Okay, coming to the pass 2, consider the output of the pass 1 as the input of the pass 2. 6, 4, 1, 2, 9. Already 9 is in its correct order. Repeat the same process. Compare 6 and 4. 6 is greater than 4. Condition is true. So swap 6 and 4. 4, 6, 1, 2, 9. Next, compare 6 and 1. Compare 6 and 1. 6 is greater than 1. So swap these two elements. 4, 1, 6, 2, 9. Next, compare 6 and 2. Here 6 is greater than 2. So swap these two elements. Next, 4, 1, 2, 6, 9. Already 9 in its right place. Okay, so this is the end of the pass 2. At the end of the pass 2, second largest element in its right place. At the end of the pass 2, second largest element in its right place. So this is pass 2. Next, coming to the pass 3, input is 4, 1, 2. Already 6 and 9 in its right places. Same process. Compare the adjacent elements 4 and 1. 4 is greater than 1. So swap these two elements. 1, 4, 2, 6, 9. Next, compare 4 and 2. 4 is greater than 2. So swap these two elements. Swap these two elements. 1, 2, 4, 6, 9. So at the end of the pass 3, third largest element in its right place. Third largest element, that is 4 in its right place. So this is the end of the pass 3. Next, coming to the pass 4. 1, 2, 4, 6, 9. Compare 1 and 2. 1 is 1 is greater than 2? No. Condition is false, so no need to swap. No need to swap. So at the end of the last pass, all the elements are in sorted order. 1, 2, 4, 6, 9. All the elements are in which order? Sorted order. So this is the logic of bubble sort. This is the logic of bubble sort. This is pass 4. Here the number of elements are 5. Coming to the pass 1, how many number of comparisons? Here we are checking 9 and 6, next 9 and 4, 9 and 1, 9 and 2. There are maximum 4 number of comparisons. Maximum number of comparisons are 4 and maximum number of comparisons are 4 and maximum number of swappings are 4. If 9 is greater than 6, swap. 9 is greater than 4, swap. 9 is greater than 1, swap. 9 is greater than 2, swap. So number of swappings are also 4. 4 swappings. Whereas coming to the pass 2, how many number of comparisons? 6 and 4, 6 and 1 and 6 and 2. 3 number of comparisons and maximum 3 number of swappings. Coming to the pass 3, how many number of comparisons in pass 3? Here 4 is compared with 1 and 4 is compared with 2. So 2 number of comparisons and maximum 2 number of swappings. Coming to the pass 4, only one comparison as well as maximum number of swappings are only 1. Okay. Next, how to calculate the time complexity based on number of comparisons. In pass 1, totally how many number of comparisons? 4 number of comparisons. In pass 2, 3 comparisons. In pass 3, 2 comparisons. In pass 4, 1 comparison if the number of elements are 5. If the number of elements are n, pass 1 contains how many comparisons? N minus 1 comparisons. Pass 1 contains how many comparisons? N minus 1 comparisons. Whereas the pass 2 contains how many comparisons if the number of elements are n? Pass 2 contains n minus 2 number of comparisons. N minus 2. 5 minus 2 is nothing but 3. 5 minus 2 is nothing but 3. Coming to the pass 3, how many number of comparisons? N minus 3. 5 minus 3 is nothing but 2. Up to so on, up to so on. Finally, 3, 2 as well as 1 number of comparisons. Okay. Add all these comparisons. Add all these comparisons like n minus 1 plus n minus 2 plus up to so on plus 3 comparisons plus 2 comparisons plus 1 comparison. Okay. It is something like sum of n natural numbers. Okay. What is the sum of n natural numbers formula? N into n plus 1 by 2. But here in place of n we are having n minus 1. In place of n we are having n minus 1. So n minus 1 into n minus 1 plus 1. N into n plus 1 by 2. In place of n, n minus 1. So by 2. So what is this one? N into n plus 1 by 2 only. N into n plus 1 by 2 only. N square plus n divided by 2. While representing the time complexities, remove the lower order terms and remove the constants. 2 is the constant, remove it. N is the lower order term, so remove it. So what is the time complexity? We go of n square is the time complexity. We go of n square is the time complexity. Next one is example animation.